Hi, everybody. I thought I would make a short video that goes through chapter 11, which is the chapter that we're uh, seeing this week 10. And we've already seen some of that in week 9 before the Thanksgiving break. So we already touched on most of the things. So all I'm going to do here is go through the chapter section by section, reminding you of what's there, highlighting things that are important to read, and that you might want to be asking me questions. And then many of the things that we'll talk about here that are in this chapter have separate videos for them, and you should go and take a look at those videos. So that way you'll have a pretty good idea of what this causal effects that are credible is all about. So we usually think to have a credible estimation of what we'll call a causal effect, that is, X causes Y, and we're estimating the magnitude of the effect of the change in X on the outcome Y. Um, We'll think of indicators of validity, and we'll think of robustness. Validity indicators, right, we've mentioned are omitted variable bias, simultaneous causality bias, reverse causality bias, sample selection bias, and measurement error of the X variable. Those are four important validity issues that we think about. Robustness, as we've seen throughout Econ 42, is about having different specifications, whether it's a log specification, whether it's interaction terms, and showing that the main effect that we're estimating is robust to a variety of different specifications. So it may, for example, turn out that there's some relationship between an X variable and a Y variable, between education and earnings, and that relationship is quite different for men or girls and boys, men and women, girls and boys. They're getting the schooling. They might have very different earnings, so the relationship might look very different for them. So that's not a validity issue. It's more of a robustness issue or a specification issue. So we'll think of those, the wording here isn't all clear. These words are not used exactly. There's not precision in the use exactly, but validity issues we'll usually think of meaning those four that will we've talked about: omitted variable bias, sample selection bias, simultaneous or reverse causality, and measurement error. And then we'll think of robustness issues as being these other kind of broader specification issues, where also robustness is about external validity. We might estimate a relationship for Kenya between earnings, between education and earnings, and we'd be interested to know whether the same relationship holds for Tanzania or for Malaysia or for Brazil. So that would be the external validity issue. Does education generally around the world lead to higher earnings for people who get more education? So let me switch to layout view as I work through and we'll make this smaller and clear this out. So the chapter has a short introduction, which I'd of course encourage you to read. And then we have some definitions of what we mean by credibility and validity, which we often distinguish between internal validity and, as we'll see down here, external validity is right there. Let me erase these and redraw them. External validity. So it should be pretty clear. These are pretty obvious concepts, so you should be pretty clear you are comfortable with external and internal validity issues. And so as we noted, we talk often about specification issues, and specification issues are related to robustness and also to internal validity. So there's some overlap between these two. So there's no exact definitions of these as applied in econometrics concepts. So you should context. So you should be familiar with them broadly and not get them completely wrong. Uh, So that's the general introduction. And then we go to some of the validity issues. And let's see, here's our validity issues. So omitted variable bias is our main validity issue. We have our conditional mean independence assumption that we have a separate video for, and that is mentioned. Where is it? Thought it was mentioned somewhere down here, uh, but maybe it's not in this section. Sorry. So omitted variable bias, we have many different explanations of it. We have a whole chapter on it. We have a whole variety of videos, so won't say too much more about that. Something that we haven't talked about too much in class until now is what we'll call imperfect multicollinearity. We've talked about perfect multicollinearity when you have variables that are linearly related to each other, and we sometimes call that the dummy variable trap when it's in the context of dummy variables. We have north, south, east, and west for dummy variables. And if we include all four, there's perfect multicollinearity there because one dummy variable is simply a linear combination of the others. North is equal to 1 minus south minus west minus east. But perfect multicollinearity can arise in other settings too. Imperfect multicollinearity means we have two variables that are very closely correlated. That is, they're kind of all, both variables are telling us the same information, the same thing. How many hours you study is equivalent to how intensely you study. So people measured how many hours they study. They might say, oh, I studied 50 hours. If you separately ask them, how intensely did you study on a scale of 1 to 10, then right, the more they studied, the more intense they might say they studied. So those are two related measures. So when you have two very closely correlated measures, we'll have a situation in econometrics and regression analysis is called imperfect multicollinearity. And basically the problem is one of the coefficients might not be statistically significant and might have a very strange coefficient on it. So that arises when you have imperfect multicollinearity. The only way to know whether you have that situation is to use your reasoning and to do the correlation between these two explanatory variables. If it's above 0.95, then you're definitely in a situation of imperfect multicollinearity. If it's 0.9, maybe you still have a problem. If it's lower, it all depends on what the other variables are, because two variables might appear to be correlated. But if you control for a third variable, then those two variables might not be as correlated as there. So it's an intuitive concept, not one that we exactly measure here. So that's imperfect multicollinearity. We've talked in class about specification choices, functional form, and using interaction terms. Here's the discussion of conditional mean independence that I mentioned, and we have a separate video on this, and you should take a look at that at that video. So we'll continue going down here. We have, I'll let you read all this stuff. A little discussion here about bad control variables, and I think that's pretty interesting. A bad control variable arises when you include a variable in your regression that lies along the chain of reasoning from your X variable to your Y variable. So our case that we've discussed at length is that education affects earnings. On that chain of reasoning, education affecting earnings, education might affect your ability to get a first job after you graduate. So you get education, you get a first job, and then you start your earnings. Including a control for getting that first job or what the quality of the first job is, that's a variable that's sort of a bad control variable in the relationship between education and earnings because it lies on the chain of reasoning that goes from our X variable to the Y variable. So we usually don't want to include variables that lie along the chain of reasoning from the X to the Y. Those variables that are intermediate outcomes should not be included in regression analysis. So that's this question of bad controls. Let's continue on down here. We've talked about measurement error in class. I'm not going to have you go through the algebra of measurement error in the X variable in particular. So it's good algebra. Encourage you to learn it if you like. It's just 2 pages of algebra. So if you really want to practice your covariance operators, then definitely be thinking about this. But otherwise, we'll be content with our general presumption of measurement error, which is if in a single variable regression context, if the X variable is measured with error, that would lead to what we call attenuation bias. Our beta coefficient will be biased towards zero. Whether it's a negative or a positive coefficient, it'll be biased towards zero. Attenuation bias. So that's conclusion given right here. You can skip the box and just read the discussion in the text for that. So measurement error in the X variable leads to attenuation bias. Our beta coefficient is biased towards zero. Then we have discussion of simultaneity, simultaneous equation bias, and we have the same discussion that we did in class, and there's a video on this, so I won't cover this anymore. We have sample selection bias. We covered that in class. We gave numerous examples in class and in videos, so you should be aware of that. The airplane example is a cute little example of, sample selection bias. And external validity is pretty obvious. Then the chapter goes on to discuss checking for robustness, which we've been doing in Econ 42 extensively, making sure that when we run an equation, estimate a relationship, we do a variety of specifications of that relationship. And we talk here about some ways that a researcher might ensure or communicate to the research audience that their results are robust, making their data publicly available, presenting greater online appendices for additional regression examples, including multiple data sources, and pre-registering analysis before the analysis actually run, so that researchers can say, okay, you stated your hypothesis and then you went and did your analysis, rather than you went and tried a whole bunch of regressions and then claimed that the one that had a p-value less than 0.05 was the hypothesis you were interested in testing all along. That would be bad research practice. I think that's pretty much it for this chapter. I've a separate video on section 5, so you should take a look at that video on these kind of example regressions.